All right, so let's get started. So we'll be using Python for our code. First I'll just give you a step-by-step an overview. So basically we will start with creating an environment which will replicate to similar to this multi-armed bandit. So the unique combination of these four parameters will be, one of the levers, and now total number of such parameters will be total levers. So let's say we have 25 male New York iOS. Similarly, we have 25 male New York iOS again. So these would be considered one lever. And similarly, we will have Android like that. All these unique combinations, we will have n number of levers based on that. Okay, so that's the idea. First, we'll create an environment where we can have all these processes going on. So we'll create that environment, and then we will go for the simulating it through these four methods. So random approach, greedy, epsilon greedy, upper confidence bound. Okay, so yeah, let's get started. Let's start with the import. So I'll just show necessary imports. For this case, we will be just using pandas and numpy. In the next of some tutorials where we do some advanced analysis, we'll be using other ML based libraries. So you want to use annotation, so I am using this one. So basically this is when you are referencing something before it's declared. I'll show you when we create classes, then it's good. I mean, generally in Python you don't use types, but it's good, to have it, and I'll show how it where it will be useful. Then from pandas, I would import read_csv because we will be using a CSV file to do all this. And then from numpy, import argmax to find the maximum arg. I mean, I'll tell you what these functions do. Argmin and I guess log, because in upper bound confidence level there's a formula. This one, previous estimate plus 2 times ln of t under root ni. So root, I think square root also we will need. So sqrt. I can remember these many for now. So let's move ahead. So let me just execute this. It's asking me to install something. Let's try that. Okay, so I think this one is done. Yeah, so this is compiled. So let's start to create environment. Okay, we will define the constructor in it. Okay, and since it's a self, now to cast the type, here is where you will need these things. Okay, and then other thing would be the data, which would be pd. Okay, I think I'll just export data frame. Okay, I guess let me data frame. All right, and here we will do self.data equal to data because we want to keep this available. Okay, and then I'll see. So first thing is we need to create an agent. Will be this thing which will interact with the environment. So we are defining all the environment. So we will do compute reward. Okay, so in this one I don't think we need anything special. Environment, I mean, these type casting thing is not necessary. However, it's always good to mention them so that your code becomes more readable, I mean, and even more explorable. Anyways, so in compute reward, let's pass it for now based on the rules that we had, that is gender equal to male would mean 70% chances of performing a click, and gender equal to female would mean 30% chances of performing a click. Okay, I mean, this could be anything, it's not very specific to this, but we could specify like based on the data that we have. We can maybe Android users will have 50% chances, iOS will have 30% chances, others will have 20% chances, something like that also we can define. Okay, so let's have a function to compute and assign initial probabilities. Again, self, which is environment. Okay, so here what we need to do is compute and assign initial probabilities. So but before that, let's save this and let's do a step for exploring the data so that we are familiar with what all is there. So path equal to r of, I think it's known as CTR dataset. Okay, now we will do is data equal to pd read csv of path and then data dot head. Okay, so we can see that this is a kind of data, and we can find the unique entries by group equal to data dot group by, and here we will use age, comma gender, comma city, comma phone underscore os. Okay, so this will give me the group data, but I want to use this as arm id. So basically all the unique combinations of these would be my arm ids. Okay, and that's what the plan is. So we want to group this together and then generate, so we can use dot n group. Okay, and I'll show you how does this look like. So let's say print grouped, or maybe let me try and see if I can do group dot head. Not sure if it will display, but let's try. Okay, yeah, so you can see that it's 1 2 3 4 25 26, something like that. So basically it generated all the index, and if I make it more clear now, let's see how this looks like. So you can see that there are 779, and so we can do number of or total arms equal to grouped dot n unique. Okay, and if I print actually let me use total arms like this. Okay, so we have total 780 unique combinations, and if we do a normal thing like let's say print data dot size just to see if these combinations are all unique, so you can see there are total 3120 entries, out of which 780 unique combinations we have. So unique combinations meaning unique combinations of age, gender, city and phone OS. It's not like one of these, but all four taken together. So for a given age and a given gender and a given city and a given phone OS, the number of unique combinations are this. Okay, I hope you got the idea. All right, so this is just a pre-analysis. Now based on this, we will maybe have something like here only let's compute these things. So we will do grouped equal to self dot data dot group by, and I think I can just copy this thing because we don't want to repeat it again. Okay, and then once we are done with this, then we can calculate self dot total arms as n unique. Okay, because we will be using this information. Now not to confuse, like we will use it like this. Okay, so n group basically generates it in terms of IDs. Okay, not like 1 2 0 1 2 and so on. Okay, so what I want to do is now map this to a specific probability, and like 0 would have some probability, let's say 0.2, then 1 would have some probability, 1 meaning the first ID. Okay, because this combination age, gender, city, phone OS, it's not like like let's say if the age is something, I think we have got rid of that, but yeah, like let's say age is 10, gender is male, city is New York and phone OS is Android. So it would be referencing to a specific number, for example here 0, and like let's say first index is 0.3, then second index is 0.4, and this number is corresponding to specific age. So let's say 12 years, male, New York, let's say iOS. Okay, similarly the second index will be again corresponding to a second unique ID, and that's what this n group is doing. Okay, so this maybe, let's say this will be female and so on. So like this we will have all these 780 combinations, and we want to compute probabilities of all these based on the logic that we have written here. Okay, so let's do that. Self.total_arms. So we will do it like this, and I guess we can get rid of pass. For I in range self.total_arms. Okay, so we want to iterate through each of these and then generate a probability. So first we need to do arm data, which is corresponding to the self.data, where okay, and actually we'll have to assign this group to something, no, because otherwise we won't be able to see like how do we determine the arm ID for a specific group. So we need to assign that as well. Okay, so let's actually do it here itself. Self.data of arm_id equal to grouped. This will help us to create the a unique field arm ID. And here what we will do is we will capture all such data. So self.data of arm ID double equals to I, meaning that give me all the data which is belonging to this particular arm ID. Okay, now from here we can compute the probability equal to arm_data, where gender equal to male, and we want to take a average of all these, so dot mean, and the probability of clicking by male is 70%, so we will do 0.7 into this thing, and then plus, similarly I hope you guessed it, 0.3 times arm data gender equal to female mean. Okay, so this will be probability. And now we have let's assign these probabilities also. So self.probab equal to, let's assign it as an empty what do I say, as an empty dictionary, and then for each ID we will assign these probabilities. So I equal to probability. Okay, I hope you are getting the idea what is happening and everything. So basically now we have this these are like total 780 arms. Okay, out of which we want to pull, we have computed probability of each of those, and we are assigning that here. Okay, so that is a part of this function. And once the constructor is initialized, we would like to compute all these probabilities, so we will call this method. Okay, so this is part of the probability. Okay, now compute reward. Now the reward of a successful, we have the probability and everything, that is fine. Now if we want to successfully capture that, then what we need to do is since these arms are randomly rewarded, so we would use another function from NumPy, which is random. And let me run this again, and maybe this one also. Okay, and here what we will do is compute reward. So random probability equal to random dot I guess random dot I think we'll have to do random dot random. Yeah, so this will give me a random number between 0 to 1. And now this, if this random probability if our current probability is greater than this random probability, then we will assume that it's a positive reward. Okay, so return 1 if and actually we'll also have the arm ID, because we need to reward based on that, and we will return a float value. So return, actually not float, int, return 1 if self.probabilities.get arm underscore id comma 0. So what this says is that get the for the given arm id, whatever the probability is, get that, and if it is not found, return 0. If this is greater than random probability, else 0. Okay, I hope you understood this condition. So we are saying that if the lever is pushed and the probability of that lever to be, to be clicked is the goal here, which is positive, meaning 1, we won. If it is not clicked, then 0. Okay, so if this probability is greater than the random probability, that means we succeeded and we will return 1, otherwise we will return 0. Okay, so this is the second part. Let's first compile it to see how it's going on. Yeah, so this is done. Okay, so I guess this is the basic environment. We will see how we can, if we need to add other things, but for now I think this is good enough.